From awaytogarden.com and robinhoodradio.com, this is A Way to Garden with Margaret Roach, your weekly invitation to dig in and grow.
So-called crazy worms or Asian jumping worms, several invasive earthworm species that are spreading alarmingly in many areas and degrading soil and natural habitats, are probably the most common pest question I get from readers and listeners in recent years. Many of you have asked specifically, how can I stop them? So to find out what scientists know so far, I called researcher Brad Herrick of University of Wisconsin-Madison, who gave us a 101 last year on these destructive worms and has since published some new insights that may in time help to lead to answers. But first, this message.
Underwriting support from Timber Press, your go-to resource for books in gardening and nature. Whether you're a new gardener, a professional at the top of your field, or a reader interested in the wonders of the natural world, their books are there to help you grow. timberpress.com.
Brad Herrick is Arboretum ecologist and research program manager at the University of Wisconsin-Madison Arboretum, where the staff first noticed the destructive effects of Asian jumping worms in 2013. He's been studying them ever since. Welcome back to the show, Brad. I wish we had a more optimistic topic to discuss.
I know. Well, thanks for having me anyways.
We can talk about plants someday, right? Because I know you
Yeah, that'd be great.
I like plants and you like plants.
That's right.
I don't like Asian jumping worms, Brad. Oh, my goodness. So,
yeah, I know. It's one of those things that is another invasive species, but from the research end of it, actually, it's very interesting to study and try and get some information out to folks.
So in case people don't know the basic issue with these worms, because, a lot of gardeners, as we talked about last time we spoke, earthworms are good, blah, blah, blah. Can you explain why these species are so worrisome? And they're not something that's new. It's just something that's reached sort of a tipping point, I guess. We know more about them now. Yeah.
Exactly. Yeah. So definitely, in terms of the gardening community, we've been told for a long time that earthworms are actually a really beneficial component of the soil environment. Right? They create through their burrowing, their feeding behavior, their creating castings. They produce a lot of nutrients, and they work those nutrients throughout the soil column. They mix soil, and that's that they provide, their burrows provide areas for air to reach the roots and water to reach the roots of plants. So generally, they have been thought of as doing a kind of a beneficial ecosystem service, if you will, for our vegetables and our garden plants. And that's still the case, except that now we have a kind of a new twist on it, where we have these newer invasive earthworms from parts of Asia that don't behave quite the same way as the earthworms that we're used to. And what I like to tell folks is that even earthworms that are in your garden, if you live in glaciated areas of like New England area, Upper Midwest, where I'm from, there are really, if none. I should say no native earthworms, or if there are, very few. It's thought that the last glaciation kind of extirpated them. And so our systems aren't really familiar with earthworms, and don't especially our high-quality areas don't need earthworms to function healthy.
Right.
So anyway, these, even though earthworms in your gardens are also non-native, but they do perform a benefit. These new earthworms, they don't do the same kind of burrowing. They don't burrow vertically into the soil. They're not really good at mixing nutrients or mixing soil. They do all their work in the upper few centimeters of soil, or even above the soil within whatever organic layer you might have in your garden. And they turn over. They eat the organic layer, whether it's leaves or mulch, decomposing wood. They eat it really quickly, especially when they get to high numbers later this summer. And they turn it over so fast that they release all those nutrients really quickly, like a quick-release fertilizer. And it's often two things happen. One is they release it so fast, and they're not mixing that nutrient back into the soil, and so it's often lost through heavy rain events, or just not available to the roots, which are lower in the soil. And they're often doing most of their work later in the summer, when really plant growth isn't the main the main thing that plants are doing. They're thinking more of storing nutrients for the winter if they're perennials, and so it's sort of there's a bit of a a mismatch in terms of timing as well.
Really out of sync, and they kind of reduce the soil to almost like, I don't know, it's like as you say, they take out all the organic matter. So, I've read these reports in the Great Lake Forest and in the Smoky Mountains and places, natural areas where what they talk about tree root gingivitis, where, where the roots of the trees can't even get a hold and stay, what I mean? The soil is being so degraded.
Yep. As I say, in highly degraded areas, you'll see tree roots that are above the soil. You can actually see the roots. They're not actually... because all the organic layer has been removed, so you're down to mineral soil.
Yeah. So I'll link with the transcript of this conversation that we're having today to our previous one that has more in-depth sort of the biology and so forth of these worms. But I saw a map on, I think it was like maybe Oregon State University's website, I'm not sure, that showed what states are affected. And I was curious, it didn't say what date it was or whatever. I wondered how wide-ranging is the impact of these worms now? And there's two genera. Are they from two different genus of worms? Is that?
I think we have confirmed around 17 species of what are called ferritomoid earthworms, which are these Asian earthworms, and there's many different genera. We have primarily two, I believe. So Memphis is kind of the largest genre with many species that we have in the U.S., or actually North America. And then there's one called meadowfire, which, as far as I know, we only have one species of meadowfire here in North America.
Yes.
And there's kind of this invasion happening. It's a co-invasion with three main species, and the three species are Amenthus agrestis, Amenthus tokyoensis, and meadowfire hilgendorfi. And that's getting kind of technical, but they all live in the same area of soil. They're all functionally kind of the same.
Yeah.
They do the same kind of things in the soil. They're just different sizes, and they can often exist in different abundances. But we're trying to learn more about if there are differences in terms of how they affect the environment based on their size or feeding behavior.
Yeah. So in this map that I saw, it had these states, colored in a particular color where they were present. And again, I don't know that it didn't have a date. I just couldn't trace the origin of it. And it seemed like there was the eastern part of the United States a lot, the Midwest a concentration. In Nebraska, I read about in Nebraska. It seemed like it was a lot of different places. So I don't know how widespread we think it is at this point.
That's kind of that's what you described there. I think is what we know. I mean, definitely the southeast, up the eastern seaboard of states, and now throughout the Midwest into like the central part of the country. I know Oregon has them.
I saw Oregon as the one outpost on this undated map. I saw Oregon and that's why Oregon State University had this document. So it's not just localized to where you are or where I am or whatever, and more people are, I think, reporting it. So probably we'll find out that there's even more than we know. So
absolutely.
Yeah. So I watched a training webinar the other day with the organization called IMAP Invasives. Do you know that? Yeah. And IMAP Invasives, and we have in New York where I am, we have a particular group related to that. And, it was like a training online about certain invasive species, and one of the ones they were covering was these worms, so I watched. And they gave some sort of layperson tips for IDing them, for sort of what do you want to look for? What now that you've been studying them since 2013, if people ask you, other than doing DNA analysis or whatever, what do you say the telltale signs of these worms versus the other earthworms that we talked about?
Yeah. So a couple of things, and it somewhat depends on what time of year you're looking for them, but the first thing that you can see any time of year is this specific soil signature, and that is these Asian earthworms produce a very coffee-like or coffee ground-like signature in the soil, really loose, granular soil that's actually made up of their castings, their excrement, and so they create this layer of really loose soil, really granular soil, which all earthworms produce casts, but most earthworms produce little kind of little casting hills or little bumps, kind of sporadic around the landscape. where jumping worms just create kind of a homogenized, uniform look to it. That's one thing that you can see in the winter. If you get a snow melt, you can that as far as we know, that's a permanent change to the soil. So what's one thing. And then as they mature, so in Wisconsin, we're almost seeing mature adults. So Amenthus or jumping worms generally, if you have one and you look towards the head, even if you can't figure out which end is up, there's a white ring around one of the ends.
Right.
It goes all the way around the body, and that's called the clitellum, and that's where they produce cocoons that are the new offspring. It's kind of the reproductive center of the earthworm, and all earthworms have one, but most earthworms, their clitellum is kind of the same color as the rest of the body, and it's raised. And it doesn't go all the way around. If you turn an earthworm over, it's kind of like a saddle where it doesn't connect.
Not a band.
Underneath.
Right.
Not a band, right.
Right.
The jumping worms all have a band, and it's kind of a milky white band when they're fully mature adults.
Right.
That's a telltale sign. There's no other earthworm that isn't a jumping worm that has that kind of structure. And then lastly, just their behavior. They're called snake worm or jumping worms for a reason. They can be very erratic, they're not aggressive, they just don't like being handled, and they will flop around and they'll wiggle away. They'll even try and drop part of their tail the last several segments to escape being handled roughly. Or other earthworms are, kind of wiggly, but they're not actively flopping around.
Right.
Trying to get away from you. So and I guess maybe one more thing to mention is that early in the spring, April, May, if you're seeing fully formed earthworms, large earthworms, those won't be jumping worms because jumping worms are an annual species. And so under normal climate conditions, they're going to be hatching from cocoons. They'll be really tiny in the spring, and won't be full size until the middle of the summer, or end of the summer even. So any large earthworm you're seeing in April, May is some other species that is not a jumping worm.
Yeah. The on this training, this IMAP invasives training webinar, one of the things that they showed was the movement that you were just talking about. And they had, I don't know whether it was a night crawler or some other kind of earthworm and an Asian worm, and they compared. And it's as if the older earthworms, they kind of move forward like an inchworm, and not exactly. They don't, curl up their backs, but they move forward in a forward movement direction, as opposed to sort of this sidewinding, snake-like wriggling thing. Do you know what I mean? I mean, that was very dramatic. As you were saying. So here we are. A lot of us have them. More and more counties, each year as I read about them, I've been reading about them for a number of years, and again, I'm seeing more places on these maps and more reports from different cooperative extensions and university researchers and so forth in more places. So you are exploring with your colleagues there at Wisconsin-Madison, you're exploring some directions of what do we do, not expecting an instant answer, and I saw you recently published a paper about the heat tolerance to the cocoons, the sort of reproductive little egg sacky kind of thing, isn't it? The cocoon of these worms, and you're exploring that. I wonder if you could tell us a little bit about what you've been doing and what have you learned so far?
Sure. So we've been working closely with our Department of Natural Resources, and they're obviously very interested in statewide spread and if there are ways of controlling the spread. And so we've gotten some funding from them the last few years to explore that question of is there a way to control them? What, and if so, what's the most effective way of approaching that question? And so we think that given that these are annual species, like I mentioned, and they overwinter as cocoons, which are just little 2-millimeter size brown, like you said, kind of sacs that hold the embryo, we think that they're being spread primarily through people moving cocoons inadvertently.
Yes.
You can see the earthworms, and you can avoid spreading them. The earthworms themselves won't stick to your shoe or the shovel that you were working in, but it's going to be the cocoon that gets stuck easily in soil and then can be easily moved, or even during rain events, they can move over land. They can just come with the soil if you have erosion. So, and they're so hard, you can't see them in the soil. They're so hard to find. So we thought, is there a way that we can sort of throw a wrench into that part of their life cycle and focus on those cocoons? And what we looked at with this most recent paper is many states, including Wisconsin, have regulate compost. So large commercial composters have to follow statewide standards that are pretty standard across the U.S. in terms of state policy. But that is that depending on the type of compost pile, the pile has to be heated up to 131 degrees Fahrenheit, which is 55 degrees Celsius, for a period of 3 or 10 days, depending on the type of pile, and that includes mixing it periodically. And they do that standard is there to minimize the potential of having harmful bacteria or fungi or disease in the compost that may hurt your soil. And so our thought was, well, at that temperature, can these cocoons still remain viable? We know from previous research that earthworms themselves cannot withstand that kind of temperature. And so we basically, in the lab, collected hundreds of cocoons and subjected them to different temperature regimes from 20 degrees Celsius to 55 degrees Celsius for 3 or 10 days. We ran that for several months, and then we dissected each cocoon to see if there was an embryo or an actual worm or what was happening within the embryonic tissue. And what we found was that at 40 degrees Celsius, which is 104 degrees Fahrenheit, anything at that temperature or above contained no viable cocoons. There was not one cocoon that had a viable, from what we could see, a viable embryo or an earthworm. And so, that's obviously 140 degrees Fahrenheit is much less than 131 degrees Fahrenheit. And so the temperature that's being reached in these large compost facilities would kill the cocoons. Now, there's always, with research, there's always a caveat that, that's the temperature. It was a lab experiment, but 131 degrees is 131 degrees, and so if it's reaching that much in the compost, then we're pretty sure that if it's being mixed correctly and all the compost is getting that temperature at least 3 days, then that should be free of cocoons. Now, what happens after that, that's where we could get another, sort of an avenue for new invasion. If the equipment that they're using to move the compost to the packaging facility is not clean, that could be a source of contamination, or, you know what I mean? There's other places along that line of producing the compost that you could always have an accidental introduction. But the temperature itself is what we looked at, and at least from our study, we found that 104 degrees Fahrenheit is enough to kill cocoons. So
do you feel or hope, or we all hope, but but do you feel that ... down the road, this exploration of heat tolerance of cocoons, that there may also be some way to apply this to other than a compost setting, or what?
Right.
What are you thinking about that? Because you have them in the Arboretum. I mean, you have these worms in the Arboretum, right? So,
right, and that's the question that I've been getting a lot too. Is how, as a homeowner and gardener, how can I apply this to my yard? And that's sort of the next step. How do we apply this research now to on the ground management? And some of it may not be applicable. It's very, I think, case specific. So one of the things that we've sort of talked about is this idea of solarization of soil.
Yes.
So right, yeah. So if you have a yard or a garden that has the right aspect, it's not shaded, and you have areas that you can put down a clear plastic over an infested area of soil, It's possible that could heat up to a high enough temperature where we think the cocoons are going to be right at the surface of the soil or just below the soil surface. So you should be able to reach 104 degrees, at that soil level.
Yes, for 3 days, right.
Yeah, so
right.
that's definitely one way to do it. And actually, there's been research looking at prairie systems and using prescribed fire. And what they found was that when they put a fire through an area that had cocoons, that the fire didn't actually impact the earthworms, because earthworms could actually move below the surface far enough where they are buffered, but the cocoons were significantly impacted.
Yes.
And so we know that heat can work on the cocoons, and obviously if you do that enough times, you're going to deplete that cocoon bank, and sort of like a seed bank, right?
Yeah.
If you deplete that cocoon bank, you're going to reduce the population over time.
Yeah. So we have maybe 3 minutes, and what do you think about? I mean, so here, those of us who have them, we might consider solarizing probably can't hurt. Some cooperative extension websites I see, they say, well, when you identify the adult worms, at this time of year or a little later, put them in a plastic bag and, speaking of which, cook them to death, so to speak, put them in the sun. But I don't know. I mean, how many are there? There must be 8 billion.
Right.
But are there any other tactics that you think that in this couple of minutes that you think that we should be sort of doing at this point?
Yeah. So, and again, this is a case where the need for information is outpacing the research knowledge.
Definitely. Yes.
Yeah. Right. So, a lot of it depends on your scale of infestation. If it's a really small scale, and this is the thing about education, is knowing what to look for and identifying areas that look like they might have the jumping worms.
Yes.
If it's a really small area, you can use a simple mustard pourer. A third of a cup of dry mustard powder with a gallon of water, and pour that over an area that you think might be infected.
Oh.
And just literally pull, because then the adults, it irritates the adult skin, and they will come. Their response is to go vertically up the soil and out, and you can pick them out.
Okay.
And you can put them in a plastic bag or whatever. Over time, you'll deplete their ability to produce cocoon.
Okay.
Again, it's not a one-shot deal, but that's a small-scale remedy.
Good.
Yeah, and then again, I think it's we're working on. There's a fertilizer called early bird fertilizer that we're
and I'll give the links about that.
Yeah, doing some tests on to see what the dosage should be, and getting it out in the literature that it does work, and see if it works on cocoons as well. People are already going ahead and trying it, and I think are seeing some good results, but it can be kind of a messy process because the worms come to the surface and die.
Oh, that stinks.
And then you have worm guts laying around, which they don't. The worm body doesn't last forever, so it's kind of, if you can tolerate that.
Yeah.
So there's some kind of chemical applications. At a large scale, frankly, at a large scale infestation, we don't have. That's where our kind of our gap is
in the natural habitats.
In natural habitat, right.
Well, Brad Herrick, I'm going to keep checking in with you.
Great,
because
happy to talk.
You're my 411. Yeah, but thank you so much, and keep up the good work, because I think this is one of the really, really important problems to solve, and what you're doing is shedding a light on some of the possibilities. So thank you. I'll talk to you again soon.
Thank you very much.
Okay.
Underwriting support from Timber Press, your go-to resource for books in gardening and nature. Whether you're a new gardener, a professional at the top of your field, or a reader interested in the wonders of the natural world, their books are there to help you grow. timberpress.com.
Now, don't miss an episode. You can subscribe free to the podcast version of the show on Stitcher or iTunes or Spotify. And you can find me anytime at awaytogarden.com or on Instagram and Facebook as @awaytogarden. And happy gardening meantime.
Away to Garden with Margaret Roach is a joint production of awaytogarden.com and the smallest NPR station in the nation, Robin Hood Radio.